My job, as you said, is as a space scientist, so I'm interested in the atmosphere of the sun and how dynamic the atmosphere of the sun is, and it all comes back actually to the fact that there are very intense magnetic fields evolving in the atmosphere of the sun. And what we need to do to get our scientific questions answered is to take very high resolution images of the sun. And so, as was mentioned, in 2010, NASA launched the Solar Dynamics Observatory.
Tell us, why is it important for us to understand the behaviour of the sun and how it affects us here on Earth?
So I think the point you just said about how it affects us here on Earth is really key. The sun is our local star. What it gets up to matters for us, and it matters for us in ways that actually we could never have predicted, first of all. So for example, we have this area of research called space weather now, and space weather describes changes in the sun's atmosphere and how those changes affect us here on the Earth. And now, one of the things that I find really startling about the sun is that its atmosphere extends into space to a huge distance, so beyond Mercury, Venus, Earth, Mars, to over 18 billion kilometres from the sun. So the Earth is sitting in the sun's atmosphere, and it's a dynamic and stormy place. And when you have stormy weather in the sun's atmosphere, that affects us here on the Earth, through causing changes to the Earth's magnetic field, and then the knock-on effects sort of ripple all the way down to the surface of the Earth. They can cause problems with our electricity networks, satellites, communications, and many, many other things.
Yeah, this is something we've spoken about before with Carl, of these coronal mass ejections, which are likely to affect Earth. Particularly, I guess the most obvious would be it would affect power supply, electricity networks, and so on. And Carl, you were saying perhaps the best safeguard, if we know one's coming, is to shut everything down.
I said so, and I was wrong. I'm not an expert, but Dr. Lucie is. So we're talking the Carrington event, which caused auroras, really close to Florida, and lines, which in those days were not power lines, but only the telegraph lines, were sparking and set fire to the wooden huts. And one of these could hit us and pretty well knock us for 6.
That's right.
And you were involved with that.
So a big part of my job now is to understand not only the science of the sun and understand why we have coronal mass ejections with a view to predicting when they're going to happen, but the other part of what I do is to try and understand, well, what can we do to safeguard ourselves against space weather impacts? And so we have conversations with National Grid in Britain, and they tell me they want a 5-day warning for when a coronal mass ejection is going to happen.
But they only take a day to get here.
That's right. So they want me to sort of have a crystal ball and say, right, tomorrow afternoon, one will be launched from the sun and it will be Earth directed. We're a long, long way from that at the moment. But there's a lot we can do, even when we have seen the coronal mass ejection being launched from the sun and know that it will take perhaps 1 to 3 days to get to us.
Well, am I right in saying you're trying to get one step further by the launch of a new spacecraft which will orbit between the Mercury and the sun itself? Tell us a bit about that.
Yeah, so this is the Solar Orbiter mission, and this is such an exciting mission. It's a bit of a sort of Icarus-like mission because it will get very close to the sun, as you say. It will be in this very eccentric orbit, so it's close to the sun at one point, far away at the other point in its orbit. But the beautiful thing about Solar Orbiter is that because we'll be able to get close to the sun, sitting really in the sun's atmosphere, we will see these coronal mass ejections leaving the sun, and then they will wash over the spacecraft. And then later on, we will measure them further out in the solar system with our spacecraft. So Solar Orbiter is like the sort of missing link in the Sun-Earth connection. We see the sun, we measure effects at the Earth, and now Solar Orbiter will sit in that material and help us understand how coronal mass ejections evolve as they go from the sun to the Earth to help us with our space weather forecast.
From an engineering point of view, how on earth do you come up with a spacecraft that can withstand an environment such as that?
Yeah, what temperatures do you get on the skin of the spacecraft?
So on the side facing the sun, the spacecraft will heat up to around 500 degrees Celsius.
500 is enough to melt the lead out of solder joints.
That's right, and you imagine also that our instrumentation needs to operate at around room temperature, most of it. So we've got to create this really stable thermal environment, given the spacecraft is going close to the sun, far away from the sun, close to the sun, far away from the sun, and the engineering challenges are enormous. And then you've got to get the data back from the spacecraft too at these very distances. So the whole mission itself relies on really good engineering, and there are many different European countries involved to enable us to succeed in this mission.
Lucie, you are a fantastic example of a woman in science. Tell us a bit about how you got to this point and how you're trying to perhaps encourage girls at school to head in that direction.
So when I was at school, physics was my first love for a long time. But then later on, I moved into art. And so when I left school, I wanted to be an art therapist. And I went off and did an art course. But I soon realised that actually physics was where I wanted to be. And so I went back to university to do physics with astrophysics. And that was where I discovered the sun. And I don't know, I mean, you'll be very familiar with looking at pictures of the sun. And to me, they are scientifically interesting and artistically interesting too. So I think the sun sort of brings those two aspects together for me. But now a lot of what I do is about going into schools and talking to the general public about opportunities in science, encouraging women to come into science, not necessarily even in an explicit way, but just by being seen as a female scientist. And actually I think in astrophysics we're doing quite well because a lot of my colleagues are female. And in fact, all of the academics in my group at UCL are women.